Now, what we will see and what we will focus will be how can we charge an object? What are the ways so that we can charge an object? And in nature, three are the ways that are known to charge an object. The first one is that is known as the charging by friction. Charging by friction. What is happening during friction is that you are rubbing together two objects. Usually one is a fur or something like that, or a balloon into your hair. And the other one is usually a conducting material or something else. And then by rubbing the two objects together, what is happening is the kinetic energy of the electrons that are in the outer shell is increased and rubbed with a fur object, a fur material, and then they will find the path to go to the fur, so that the electrons are finding a way to leave or to go to the object by making the object that they are leaving as the positively charged and the object that they are going to as a negatively charged. Charging by friction is a way of charging that it's very, very, very difficult to measure what is happening between the object A and object B that we are rubbing together. However, the mechanics of charging by friction is that the kinetic energy of the electron is increased, and being in a furry material, the electrons find a way to move from one object to the other, leaving the object that they are leaving at or leaving from as a positively charged, and making the object that they are going to as a negatively charged. We will not deal too much with charging by friction. You just need to know that this is a way that we may charge an object. The second way that we charge an object is that is known as the charging by conduction. What is happening when we are charging by conduction is that the two objects are in contact with each other. So conduction starts with con, and they are in contact with each other. They are in contact with each other either by just simply touching them or through a conducting wire. And recall what I said, as a conducting material is a material that allows the electron to move freely. So you can see charging by conduction when you have either two objects are touched together, or when the two objects are connected with a conducting wire. On those cases, and on everything that you will see, when we are charging by conduction, we are dealing, as a program of study of Physics 30, we are dealing with two identical materials. So in every case, so what you will see when you are dealing with charging with conduction will be that two identical spheres, usually this is how it starts, two identical spheres are either in contact with each other or connected with a conducting wire. And what is happening on that case is that it is known as the general law of charges, or conservation law of charges. Conservation law of charges. So during this conservation law of charges, like every conservation law, we can say that charges are not destroyed, are not created, they are moving from one object to the other. And again, as I said, for the purposes of Physics 30, we will deal with identical charges. So if we have two identical spheres, let's say sphere A and sphere B, that initially the sphere A has a charge of, let's say, positive 10 coulombs. Okay, the units for charge is coulombs. And let's suppose that the charge B is again positively charged as 4 coulombs. So now when they are either in contact with each other or connected with a conducting wire, so you may see this case, version 1, I will say, that the two charges A and B are in contact with each other, or version 2, when the two charges are at the original positions, so charge A and charge B, but they are connected between each other with a conducting wire. Which is the same thing. So both are assuming the same thing, are assuming that the electrons will freely move from A to B or from B to A. And then they are placed at the original position. So A is placed here and B is placed here at the original position. So by touching those two objects or by connecting them with a conducting wire, what is happening, original position, what is happening is that the electrons are evenly distributed between those two objects. What does that mean? That means that if one electron has absence of the, if an object has the absence of the electron and the other object has an excess of electron, is willing to give those electrons to the other one. In this way, after you keep them either in contact with each other or connect them with a conducting wire, what is happening on this way is that the two charges, after you cut the wire or after you place them into the original places, the two charges QA nu and QB nu will be equal to each other. And based on the conservation law of charges, will be equal to the average of the previous one. So will be QA plus QB over 2. Or we had QA as positive 10 coulombs plus QB as positive 4 coulombs, divide by 2. So now the two charges, after you are either placing them in contact with each other or connecting them with a conducting wire, will have a charge of positive 7 coulombs. Okay, and even when those two are negative or are positive, still what we will do is, after they are placed in contact with each other, what the new charges will be is QA plus QB divided by 2, or the average of the two. On the explanation, you have a positive and a negative charge. Now, you have here, you have two positive charges. I will do another example where you have two negative charges. So let's suppose that you have a charge A and or a sphere A and sphere B. Those are two identical spheres. You will not deal with not identical spheres on the program of study of physics 30. So charge A is a negative 8 coulombs, and the charge B, even when it is neutral, still will be the same. You have an example of being neutral on the explanation there. Charge B is a negative 12 coulombs. So when you are putting them in contact with each other or through a conducting wire, then the new charges will be equal to each other, Q A prime after the conducting, after the being in contact or with a conducting wire, will be QA plus QB divided by 2, or the average of the two. So negative 8 coulombs plus a negative 12 coulombs over 2 equals to negative 10 coulombs. And the third charge, the third way that we charge an object is charging by induction. When we are charging by induction, as I mentioned in the previous part of the lesson, induction, what is happening is the rearrangement of the charges within the object. So induction is the rearrangement of the charges within the object. A very typical question on charging by induction is the electroscope. Within the explanation and on the content, you see videos there. However, let's deal with the charging by induction as what is happening in the electroscope. First of all, the electroscope looks something like this. You have a knob, and which is a conducting material, and then within the knob, what it ends up with two gold leaves. So those two are gold leaves. Very thin gold leaves. Now, when the two gold leaves are parallel to each other, is an indication that the electroscope is neutral. We use gold because gold is the best conducting material, the best conducting material that we know in our nature. Even this knob here of the electroscope is a conducting material, and this stick here is a conducting material, which, as I said, it allows the electron to freely move. And after we have, or when we see an electroscope that the two gold leaves are parallel to each other, those ones, they are very thin gold leaves. When you see that, that means that the electroscope is a neutral object. When we see that the two gold leaves are open up, then we identify it as the electroscope is charged. Okay, those two gold leaves. They cannot be, the gold leaves cannot be one like this and one straight. They always will be, both of them open up if the electroscope is charged. Okay, they cannot be one open up and one to be straight, but they both will be open up if the electroscope is charged. Now let's see what is happening with the electroscope when we start and charging it by induction. So again, we have an electroscope that is with two gold leaves that are parallel to each other, which is an indication that the electroscope is neutral object. And now, nearby the electroscope, we place a rod, either positively or negatively charged. I will put one that is negatively charged, but even when you have a positively charged, the logic is the same. So when we are placing a negatively charged rod nearby the knob of the electroscope, what is happening is that the rearrangement of the charges within the knob of the electron is happening. So they are making this part here, and I will call it session A, as positively charged because the negative will attract the positive, pushing away in area B at negatively charged by making that area negatively charged. So, however, when we have this moment of the electroscope, we notice that the leaves of the electroscope still are parallel to each other, which indicates again that the electroscope as a whole is neutral. And then right after this, what do we do? Keeping the rod nearby the knob of the electroscope, what do we do is we place a grounding. So on this area here, we put a grounding, and grounding, what it is a bridge. I consider it a bridge, quote unquote, that allows the electrons to move either from the electroscope to the ground, to the earth, or from the earth, from the ground, to the knob of the electroscope. The motion ground to the electroscope or electroscope to the ground is of the electrons is defined based on the need that we have to make the knob or the area of the knob neutral part. So in this case, what do we see as soon as we make the grounding? We notice that area B is negatively charged, which means that you have an excess of the electrons in that area. Therefore, grounding is saying, I want to make you a neutral area. But how are you making a neutral area that is a negatively charged, based on the fact that a negatively charged is more electrons than protons? To make it a neutral, you have to take away some electrons from this area. So grounding will be, I will take those electrons away from you to leave you a neutral area. By doing so, we still do not notice any change within the electroscope. But then what is happening is we cut the grounding and we move away the rod. As on the moment of that we do that, we cut the grounding, so we cut the opportunity for the electroscope to become neutral. This is what grounding is. We cut the opportunity of the electroscope to become neutral. And we move away the rod, which makes the electroscope to rearrange the charges. What we are when we are doing so, we are leaving the electroscope positively charged because the electrons are going away, correct? So by leaving the electrons as the positively charged, what it is happening, it is the charges now are rearranged. And how are they rearranged? They are rearranged so that most of the charges that are over, so positive charges on this case, are within the leaves. So you will have positive charges here and positive charges here. And what is happening between the two same charges, based on the general law of charges, they will repel each other. This is why, as soon as the electroscope is charged, what you will see, both leaves are going away. Not one, but both of them are opening up. So it is true that we started with a negatively charged rod, but we ended up with a positively charged electroscope. And if we start with a positively charged rod, we will end up with a negatively charged electroscope. So if we have an electroscope that is originally neutral, the indication is because we have those two leaves as parallel to each other. And we start now with a positively charged rod. What will happen at the knob of the electroscope will have on this area A more negative charges than positive charges, and on this area B more positive charges. When we add the ground, which is like a bridge that provides electron to make the object as a neutral object. In the case when we have connected the grounded with area B that is positively charged, to make it neutral means that we'll need electrons to make it a neutral one. And then when you cut the grounding and move away the rod, what you will notice is that the electroscope is becoming now, since it has excess electrons in comparison to the neutral that was before, as a result of grounding, the electron will be, or the electroscope will become negatively charged. So you start with a positive rod in the electroscope, but you end with a negatively charged electroscope. So the last thing that I want to explain here is how the charges are distributed. So if we have a sphere, then, and let's suppose that this sphere is negatively charged, then all the charges are evenly distributed, or this is what you will see on physics 30. All the charges are evenly distributed around the outside area of the sphere. So when you have a sphere, then the charges are evenly distributed. However, if you have an object that is pointy, let's suppose that you have something like this, and this object is again negatively charged, what you will notice, the concentration of the charges near the pointy area of the object is way more than the concentration of the charges when you have this kind of flat area here. And this explains even the fact why the charges mostly go, for the electroscope, mostly go to the gold leaves, because they want kind of to escape. And then this is like called distribution of charges within an object. And when it is pointy object, it is more concentration.